Hello my dear friends, now we talk about in this session about classification of solvents. Okay, so there are various parameters, various bases on which the solvents are being classified. So here we begin one at a time. So the first part is based on protons. So based on protons, the solvents are broadly classified into two categories. The first category we talk about is protonic solvents, or we call it as aprotic solvents, whereas this one is aprotic solvents. On the basis of protons, that is H+, solvents are classified broadly into two categories, protonic and aprotic. Now, when you talk about protonic solvents, these are the solvents which have an ability either to gain or lose protons. Okay, having the ability to gain or lose, okay, or both as well. It can have both the properties, both the tendency as well, with respect to what? H+ ions. Here in aprotic, neither gain nor loss of protons. Examples can be given as liquid sulfur dioxide, liquid N2O4, benzene, C6H6. So these are some of the common examples which behaves as aprotic solvents. Aprotic. Protic means what? Having a tendency to gain, lose, or both the tendencies of protons. Aprotic means it will not have any tendency. Okay, so that is aprotic solvents. Now coming back, my dear friends, to protonic solvents. Now depending upon the ability, now I said there are three abilities with respect to protons. Number one, it can have ability to gain a proton. It can have an ability to lose a proton. You can have both the properties, and therefore protonic solvents are further subclassified into three categories. Okay, so we go into the further classification. So the first one we talk about is acidic. So as the name suggests, having a tendency to lose protons. And when you give an example, my dear friends, don't just give an example of a compound. No. You give it in terms of a reaction. That means like this. If I write on HF, it is going to give you H+ and F-. So it is going to lose proton. Okay. Similarly, if I'm going to say HCl, it is going to give you H+ and Cl-. So it is going to lose a proton. Okay. So these are the possibilities. So this is the way you need to give the example in the form of a reaction. So this is the first one, that is acidic. Next one we talk about is basic. I hope you understood, my dear friends, what am I going to say over here. Okay, आप लोग काफ़ी स्मार्ट हो तो आपको तुरंत समझ में आ गया होगा कि जब हम लूज प्रोटॉन्स की बात करेंगे तो यहाँ पर हम किसकी बात करेंगे? गेन प्रोटॉन्स की. ओके, प्रोटॉन्स गेन होता है यहाँ पर. ओके, यहाँ पे प्रोटॉन्स लूज होता है, यहाँ पर गेन होता है. तो एक और बार दोस्तों रिएक्शन के तौर पे लिखना है हमें, तो कैसे लिखेंगे हम? NH3 plus H plus gives you NH4 plus. ऐसे लिखेंगे. तो अमोनिया प्रोटॉन गेन कर रहा है, तब जाकर वो NH4 plus बन रहा है. गेन मतलब it is written on the left hand side of the reaction. Okay, so that's why we call ammonia as basic. We call HF and HCl as acidic. Okay, और तीसरा भी पॉसिबिलिटी है दोस्तों, वो भी हम लोग कंसिडर करेंगे और उसे हम लोग बोलेंगे एम्फोटेरिक, या फिर हम बोलेंगे उसको एम्फीप्रोटिक. इसमें दोनों पॉसिबिलिटी है, मतलब इट कैन गेन एंड लूज प्रोटॉन्स. तो यहाँ पे सबसे बेहतरीन एग्जाम्पल मैं आपको देना चाहूँगा, एंड दैट इज वाटर. सो पहला रिएक्शन H2O गिविंग H+ and OH-. If we are going to consider this only and only with respect to protons, then see, the protons are given and therefore it shows an acidic character. Similarly, H2O will gain H+ and that is going to give you H3O+. तो गेन ऑफ H प्लस इज अ बेसिक कैरेक्टर. ओके, इसको हम लोग हाइड्रोनियम आयन बोलते हैं. वी कॉल इट एज अ हाइड्रोनियम आयन. Okay, so you can see this, कि water can show acidic as well as basic behavior and therefore it is amphoteric. दोस्तों याद रखना, दोनों reaction लिखना ज़रूरी है. If you just write one reaction, that is not going to prove that water is amphoteric. That is only going to prove that water is acidic. Suppose you write only the second reaction, you don't write the first reaction. That is once again proving that water is basic. I want to prove that water is amphoteric, and therefore I need to write both these reactions. So this is, my dear friends, based on the first parameter. Okay, and that is based on what? Protons. General broad classification is protic, aprotic. Aprotic, no further classification. We simply say neither having a tendency to gain a proton or donate a proton. Example can be liquid sulfur dioxide, liquid N2O4, okay, and benzene, and so on. When you go into the protonic part, it has three tendencies. Either it is going to lose a proton, that is going to be acidic, or it's going to gain a proton, so that's going to be basic, or it's going to, yes, gain proton as well as lose proton, and therefore it becomes amphoteric. All right, so this is the classification on when we consider the first part based on protons. I hope you have understood up to this very well. Alright, my dear friends, now we go into the second parameter, and that is based on like dissolves like. Okay, I've already explained you about this particular principle before as well. A general principle, it is like dissolves like. Means if the solute is polar, the solvent is polar, the solute will get dissolved. If the solute is non-polar, the solvent is non-polar, then the solute gets dissolved. That is what is like dissolves like. Now on the basis of this particular principle, the solvents are being categorized into two parts. We have, first is ionizing solvents, and the another one is, of course, you must have understood this, and it's non-ionizing solvents. Once you understand ionizing, make it opposite, so you get non-ionizing. It's as simple as that. So, to begin with, ionizing solvents, the first thing you have to say is that it is going to be suitable for ionic solutes. Okay, ionizing is related to ions, and ionic solutes are also related to ions. Whereas here we'll say it is suitable for covalent compounds. For covalent solutes. Here we say that polarity is going to be high because polarity is charges. So polarity is going to be high. Okay, here I'm not going to say 0, I'll just say polarity is less. Because you know very well, covalent bonds are going to be formed between atoms of different elements. और जब अलग अलग elements होता है दोस्तों, तो उसमें polarity तो होता ही है, क्योंकि इलेक्ट्रोनेगेटिविटी में फ़र्क होता है. Okay, इसलिए हम लोग कौन सा वर्ड यूज़ करेंगे? Less. Polarity is 0, ऐसा नहीं यूज़ करेंगे. Okay, so polarity is high, polarity is less. फिर आपको पता ही है, मैंने रिलेट किया था पोलैरिटी को विद डाइलेक्ट्रिक कांस्टेंट एंड डाइपोल मोमेंट के साथ. सो द डाइलेक्ट्रिक कांस्टेंट इज गोइंग टू बी हाई. यहाँ पर हम बोलेंगे डाइलेक्ट्रिक कांस्टेंट इज लेस. नेक्स्ट इज डाइपोल मोमेंट इज गोइंग टू बी हाई. यहाँ पर हम बोलेंगे डाइपोल मोमेंट इज गोइंग टू बी लेस. नेक्स्ट थिंग इज यहाँ पर हम बोलेंगे कि इट इनिशिएट्स ऑटो आयनाइजेशन, या वी सिंपली से आयनाइजेशन रिएक्शंस. Initiate matlab start. Okay, it can contribute to the beginning of ionization reactions which involves the formation of ions. Okay, यहाँ पर cannot initiate ionizing reactions. Cannot initiate ionizing reactions or ionization reaction. नेक्स्ट इज इसका ऑटो आयनाइजेशन होता है. यहाँ पे नो ऑटो आयनाइजेशन. नाउ व्हाट इज द मीनिंग ऑफ दिस? आयनाइजेशन तो आप जानते ही हो, इट्स अबाउट फॉर्मेशन ऑफ आयंस. ऑटो मीन्स सेल्फ ऑन इट्स ओन, अपने आप नहीं हो सकता. इसको हम लोग बोलते हैं नो ऑटो आयनाइजेशन। यहाँ पर अपने आप हो सकता है क्योंकि उनका पोलैरिटी इज हाई, डाइलेक्ट्रिक कांस्टेंट इज हाई, और इस वजह से उनका खुद का आयनाइजेशन अपने आप जल्दी से हो सकता है। मैं कुछ एग्जांपल देना चाहूँगा, एंड दैट इज यहाँ पे आई गिव एन एग्जांपल ऑफ वाटर H2O, इट विल गिव यू H++ OH माइनस। Okay. Secondly, if I give you an example of say ammonia molecules, दो ammonia molecule लेता हूँ मैं, so I get NH4 plus and NH2 minus. So these are some of the examples. यहाँ पर example में क्या आएगा? Benzene, liquid sulfur dioxide, liquid N2O4. Do you remember this was the same examples I gave for the aprotic solvent also? Okay, doesn't result in charges. तो ऐसे यहाँ पर भी it is not going to result in any of the charges, and therefore it comes under the category of non-ionizing solvents. Whereas ये कुछ मैंने example दिए हैं. Examples for related to ionization part हमेशा याद रखेगा, it has to be given in the form of reactions. Okay, don't directly write down water is an ionizing solvent, ammonia is an ionizing solvent. ऐसे नहीं, इस reaction के हिसाब से लिखो so that it is very clear that yes, it results in the formation of ions. Okay, so this is the second category, my dear friends, when we talk about classification of solvents. और वो category कौन सा है? Like dissolves like. और उम्मीद रखता हूँ मैं कि आपको ये वाला part समझ में आ गया होगा। My dear friends, we go into the third category under classification of solvents, और वो है aqueous and non-aqueous solvents. When I talk about aqueous, it's simple, it's water. And when I talk about non-aqueous, other than water as a solvent. Okay, एकदम, I guess it's as simple as that. Once again I repeat, aqueous and non-aqueous. So aqueous मतलब water, और water के अलावा जितना भी solvents है, okay, we can have HF, HCl, benzene, carbon tetrachloride, N2O4, ammonia, etc. etc. वो सब कौन से category में आएंगे? Non-aqueous solvents. Okay. Now you know very well water is a polar solvent. अब वो polar solvent है, so I can consider it like this. Suppose if I take two water molecules, it gives me H3O plus and OH minus. Now if I'm going to take ionizing non-aqueous solvent, कौन सा solvent लूँगा मैं? Ionizing non-aqueous, यानी I take ammonia, 2NH3. So it is going to give me NH4 plus and NH2 minus. Okay, ये मुझे मिलेगा। अब यहाँ पर एक बात बताना चाहूँगा, and that is the cation of water is similar to the cation of the non-aqueous ionizing solvent. Okay, once again I repeat, cation of water, that means H3O plus is similar to the cation of the non-aqueous ionizing solvent. And in this case, I take an example of NH3, so it is similar to NH4 plus. Similarly, OH minus is having properties similar to NH2 minus. Okay, this is the analogy which we can talk about. Okay, तो हाइड्रोनियम आयन की जब हम बात करते हैं, RNES कंसेप्ट याद है आपको? Yes. तो RNES कंसेप्ट क्या बोलता है? जो भी सब्सटेंस पानी में हाइड्रोनियम आयन देता है वो एसिड है। तो हाइड्रोनियम आयन का प्रॉपर्टी सिमिलर है टू द अमोनियम आयन, और इसलिए हम क्या बोलेंगे कि जो भी सल्यूट अमोनिया में अमोनियम आयंस देगा, दैट इज गोइंग टू बी व्हाट? एसिडिक। तो यहाँ पर ये बोथ ऑफ दीज आर रिस्पॉन्सिबल फॉर acidic behavior. Similarly, RNES also says that those solutes which gives hydroxide ions in water are bases. So similarly, any solute in ammonia giving amide, ये इसको amide बोलते हैं, NH2 minus, okay, it's going to be what? Basic. So this is related to the basic character. Okay, this is related to basic character. This is what I mean. जब मैंने ये स्टेटमेंट लिखा उसका मतलब ये निकलता है. So I hope आपको ये समझ में आया होगा. अब दोस्तों इस पूरे क्लासिफिकेशन में मैंने 3 पार्ट्स कंसिडर किया था. The first part was based on protons, which was subdivided into 2 categories, protonic and aprotic. Protonic को further classify किया था as acidic, basic and amphoteric. Second category was like dissolves like. Under that category, sub-classification was ionizing solvent and non-ionizing solvent. और जो तीसरा और आखिरी है, that is aqueous and non-aqueous, that is water and other than water. And then cation of water similar to the cation of the non-aqueous आयोनाइजिंग सॉल्वेंट। ओके, यहाँ पर हम कार्बन टेट्राक्लोराइड और बेंजीन वो सब एग्जांपल नहीं दे सकते क्योंकि वो नॉन आयोनाइजिंग है, वो कहाँ कटायन और अनायन प्रोड्यूस करेगा। इसलिए यहाँ पर हमने कैसे सिमिलरिटी रखा है बिटवीन वाटर एंड द आयोनाइजिंग नॉन एक्वेस सॉल्वेंट। तो यहाँ पर मैंने आपको एग्जांपल दिया अमोनिया का, तो कटायन का सिमिलर प्रॉपर्टीज होगा और साथ में अनायन ऑल्सो विल हैव सिमिलर प्रॉपर्टीज। सो दिस इज माय डियर फ्रेंड्स अबाउट the classification of the solvents. I am very sure you must have understood this very well.